Hi, welcome to heap sorting. Heap sorting used to arrange the elements in descending order or ascending order. Here we are having the two types of heaps, max heap and min heap. So max heap is used to arrange the elements in descending order. Min heap is used to arrange the values in ascending order. Here we are going to build the max heap. So building the max heap is called heapify process. Here we will insert the value into the tree, and we will check by using the structure property and heap property. So when you are inserting the element, if it is not satisfying the heap property, we should make the adjustments. Then we have to swap the root with the last element in the tree. That means root value is I, then last element will be index number n. So we have to swap these both nodes. Then we can delete the last node that is swapped in the previous step. Okay, so once you swapped the node and deleted the node, it will disturb the heap property. Then again we have to check the heap property by calling the max heapify process. This step has to be repeated until one node is remaining in the heap. Then by deleting the nodes, you can store that deleted nodes one by one. It will create the shorted array. We will see that now. First we will build the max heapify by calling the max heap function. Here the length is assigned, array length is assigned to the value n. Then we will start from the internal nodes from n by 2, length of the array by 2, then until we will reach the index value 1 of the heap. We will decrement one by one. In the max heapify, we will check the parent value is always greater than its child, otherwise we will swap the parent value and its children value. So this is the max heapify process we have seen in the previous session. Once it is done, then we can delete the node. We can swap the node. Okay, we can swap the node by using this code. Okay, here we will swap the index value n and index value 1. Okay, index value n and index value 1. Once it is swapped, then we have to check the max heapify process. So after that we will decrement the I value by 1. Once you are decrementing the I value by 1, automatically that node, nth node, will be deleted from the heap. So that is the thing here. So now we will take the given array is having the 4. 4 is created a node. The node is inserted into the tree. So we have inserted and we are creating the temporary array 4. Then next node is 1. So here left node is missing, so we are going to add that 1 into the left node. So here we are checking the heap property. So heap property is satisfying, parent is greater than the child value 1. Then we are going to the add the 3 into the heap. So here right child is missing, so right child is 3. Now we are checking the heap property. 4 is greater than 3, so it is satisfying the heap property. Then next node is 2, so 2 is added into the heap. So when checking the left subtree, here 1 is missing the left subtree, so we are adding the 2 as a left node to the 1. So here parent value is less than the child. So it is not satisfying the heap property. We have to swap it by applying the heapify process. So what we will do, we will swap the 2 and 1. So the 2 and 1 is now changed. So now again we are checking with its parent, it is satisfying the heap property. So now 1 is stored in the temporary value. Now again we are inserting the 16, inserting the 16. So when you're inserting the 16 into the heap, so this value is missing. Okay, right side value is missing in the left subtree of the 4. So we are adding the 16 as a right child to the 2. So now again it is not satisfying the heap property. We have to swap the parent and child. So these two are going to swap. So we are swapping by applying the heapify process. Then again you look at that, we are checking the 16 and 4, 16 and 4. Again it's not satisfying. We have to satisfy, we have to swap the 16 and 4. After that 16 will become a parent and 4 will become a child. So next all are satisfying the heap property. Now we are going to add the 9. So 9 is added. Here the right left subtree is filled. The right subtree left child is missing. So 9 is added as a left child to the tree. Then we are checking the heap property. Heap property is not satisfied. So we have to swap the 9 and 3. So 9 becomes parent, 3 becomes child. So now heap property is satisfied. Then we are going to add the 10. So 10 here we are adding as a right child as per the structure property, binary structure property. So almost complete binary tree. So now 10 is this one. So here again heap property is not satisfied. This is I mean child is greater than the parent, so it is not satisfied. We have to swap the 10 and 9. After swapping the 10 and 9, so 10 become parent, 9 become the child. Now it is satisfying the heap property. Then we will add 10. uh, uh, 10 is already added. 14 is going to add in the heap. So 14 in the left subtree, left child is missing. So we are adding the 14 as a child to the 1. Heap property is not satisfied. So we have to swap this. So 14 become parent and 1 become child. Again it is heap property is not satisfied. 14 should be exchanged. So 14 become parent, 4 is child. Now the heap property is satisfied. Once heap property is satisfied, then we will add the 8. So here a right child is missing, so we are going to add 8 as a right child to the 4. It is added. Now we are checking the heap property. It is not satisfied, so we have to swap the 8 and 4. So 8 and 4 is swapped. Now we are checking the heap property is now satisfied. Then we are going to add the value 7. So here 7 we are adding in the left subtree of the 16, and here the 2 is missing the right left subtree. We are added here. Again here heap property is not satisfied. We have to swap the 2 and 7. So we are swapped the 2 and 7. So 7 becomes parent. Now heap property is satisfied. So this is the way to create the heap. Okay, to create the heap, this is the heapify process. So we have created the heap. Once you have created the heap, the next step is we have to swap the root node and last node. So that's what we have to do it now, swapping the root node. Maximum element is root node. Okay, root node, and swapping the last index. So the last index is the 10th index. The 10th index is this one. So we are swapping this. So 2 becomes parent, 16 becomes the last node. Once it becomes last node, after swapping, right, after swapping, what we are doing, we are decrementing the I by 1. So automatically the I is here 10. I is here 10. So 10th node will be deleted. 10th node will be deleted. So after deletion, this will be stored in the array, temporary array. So delete the last node 16 from the heap and stored in the index number 10. Index number 10. Okay, so once it is deleted from the 10, now this is the tree. After deletion, this is the tree. Then now we have to apply the max heap. We have to apply the max heap. Okay, so because the 2 is parent is less than the children, less than the children, so we have to apply the max heap. So we have to swap this 2 and 14. So we are applying the heapify, we are swapping. So after swapping, still it is not satisfying the heap property. So these are all again exchanging, right? So now this is also exchanging. right? After exchanging, here still it is not satisfying the heap property, so we are exchanging the 4 and 2, so 4 becomes parent, 2 becomes child. Now heap property is satisfied. So next what to do, we have to swap the maximum element, that is the root, with the last element 2 and 14. So that we have to swap it here. So swapping the 2 and 14, after swapping we have to delete this. So 14 will be deleted and store in the last index, I mean ninth index. Okay, then after deletion our tree will be look like this. So here again we have to check the heap process. So when you are checking the heap process, heap property 2 is the value parent less than the children, so we have to swap it. So here 2 and 8 has to be swapped. So after swapping, your after swapping, so not 2 and 8, so this is the highest value than this one, right? So 10 and 2 are swapping, 10 and 2 are swapping. So after swapping still it is not satisfying the heap property, so 9 and 2 are swapping, right? So 9 and 2 are swapping. So after that, 9 become parent, 2 becomes a child. So now heap property is satisfied. Then we have to swap the root index value and 2. So we are swapping that. uh, so here, after swapping the deleted node 10, root node is 10 is deleted. Okay, so here, once the 10 is swapped with the, sorry, not this one, this is the last index, 8 is the last index. Okay, so 8 is the last index, 10 and 1 is swapped. So 1 become parent, 1 become parent, 10 became a child, then 10 will be deleted from the heap, so it will be stored in the array. So after deletion of the 10, we are getting the heap like this. So now still it is not satisfying the heap property, so we are swapping the 1 and 9. So 9 will become the parent and 1 will become the child. Still it is not satisfying, 2 will become the parent, and here 2 will become the parent. So here 3 is there, am I right? 3 is there, so 3 will become the parent. So after that, we will get this one. This is satisfying the heap property, right? Heap property, once it is satisfied, once it is satisfied, this is the final one. So once it is satisfied, then we are swapping the last index and 9. So last index is 2, so 2 and 9 are swapped. Then after that we are deleting the last index, so 9 is stored here. So once 9 is stored here, then we are checking the heap property. Heap property is not satisfied. Here 8 is the highest value child, so we have to swap the 8 and 2. So 8 and 2 are swapped. After that, again this is not satisfying. 7 and 2 are swapped. So now everything is satisfied. So once it is satisfied, now we will apply the swapping process. 8 and last index 1, so 1 become parent, 8 become the last node. So now we are deleting the 8. So once it is deleted, we will get the tree like this. Again we are checking the heap property, it is not satisfied. 7 is greater than the 1, so we will swap it. So 1 and 7 are swapping. Once it is swapped, again uh, here the 4 will become, I mean 1 will become here. Okay, 1 will become here, 7 will become here. So still this is not satisfying the heap property, so we are swapping this also. So 4 and 1. So once it is done, now we are having the heap with the satisfying heap property. Now you are exchanging the 7 and 2. So then you are, after exchanging, deleting the 7. Then after deleting the 7, again the heap property is not satisfied. So now deleted node 7 is stored in this index where we have deleted. And again checking the heap property, is it is not satisfied. So 4 and 2 will be exchanged. So once 4 and 2 will be exchanged, now satisfying the heap property, so exchange the 4 and 1. So exchange 4 and 1, then delete the 4. Once deleted the 4, now we are having the heap like this. So still it is not satisfying the heap property, this one. So 3 will be swapped. Then after that uh, 3 and 1 will be swapped. So here after that uh, uh, the 3 will be deleted, that will be stored in the index 3, index 3. Then we are having the 1 and 2, again apply the heapify process. 2 will become the parent and 1 will become the child. So it will be swapped again. After swapping this will be deleted. So now we are having the only one node. Finally this will be stored in the index. So finally we have arranged the data in ascending order. So max heapify used to arrange the data in ascending order, not in descending order. Initially I have told descending order. Actually max heapify is used to store the values in ascending order. Min heap is used to store the values in descending order. uh, the time complexity is here. We are tracing the path from root to leaf node. So the highest path is the height of the tree h. At each level we are taking the two comparisons. So total number of comparison will be height of the tree into 2. Running time is order of the height of the tree, so that is the log n. So running the max API is the order of log n. So we can, or we can write the height of the tree. Thanks for watching.